Hello everyone. In this video, I am going to explain you about procedure for doing graphical convolution on continuous time domain signals. Here, these are the steps we are going to use when we are performing graphical convolution on continuous time domain signals. Here, the step 1. For the given signals x of t and h of t, we have to graph that signals as x of tau and h of tau as a function of independent variable tau. And the second step, obtain the signal h of t minus tau by folding h of tau about tau equal to 0 and then time shifting by time t. And the third step, graph both the signals x of tau and h of t minus tau on the same tau axis beginning with very large negative time shift t. And step 4, multiply two signals x of tau, h of t minus tau and integrate over the overlapping interval of two signals to obtain output signal y of t. And step 5, increase the time shift t and take the new interval whenever the function of either x of tau and h of t minus tau changes. The value t at which the change occurs defines the end of the current interval and the beginning of a new interval. Now, calculate output signal y of t using step 4. And in step 5, we have to repeat the step 5 and step 4 for all intervals of time. In this manner, by following these steps, we are going to find out graphical convolution on continuous time domain signals. Now, we will perform graphical convolution on one example. Now, here is the question. Find the convolution of following signals. X of t is equal to e power minus 2t into u of t. H of t is equal to u of t plus 2. Means here, they given two continuous time domain signals like x of t and h of t, and we need to perform graphical convolution on these given two continuous time domain signals. By that, we may find out the output signal y of t. Now, here is the principle. To find out output signal y of t is equal to x of t convolution h of t. Nothing but these are the given signals. We are using x of t and h of t. And the principle is going to be y of t is equal to integration minus infinity to plus infinity x of tau h of t minus tau d tau. Already we discussed about the steps should be followed to perform graphical convolution. In that, step 1 states that first we need to draw the given two continuous time domain signals x of t and h of t. Now here, this is the figure A, which is going to show the given signal x of t e power minus 2t into u of t. In this manner, we may draw the given signal x of t. And this figure B shows the given signal h of t. Nothing but it is equal to u of t plus 2. In this manner, we may draw the given h of t signal. And in next step, we need to draw the given signals in terms of independent variable tau. So for that one, the given signal x of t, we are going to draw with independent variable tau in this manner. And then we need to draw the second signal h of tau also. After that, we need to find out the reversal signal h of minus tau. So this is the h of minus tau reversal signal for h of tau. Suppose this is given signal h of t means h of tau is also in this same manner with independent variable tau. In place of t, we need to write down tau independent variable. Then for that, the reversal signal must be in this manner. And this figure C and figure D is going to show the signals with independent variable tau. Then in next step, we need to draw both the signals x of tau and h of minus tau. Nothing but we need to consider here time shift t. So that we may draw both the signals x of tau and h of t minus tau on same tau axis. So here we are going to considering in the h of given signal h of t minus tau, we are going to consider the larger negative time shift. Means we are going to consider the most negative number in place of this time shift t. So by this way, we may draw the x of tau as it is from this figure C, and h of t minus tau we may draw with a large negative time shift, means it is going to start in the only negative time instant. And here this 2 is going to be nothing but representing this as it is given signal h of minus tau. So this is going to be started t plus 2. T is going to be the large negative number. When we are drawing given these two signals on same tau axis, there is no overlapping in between these two signals. So, if there is an overlap between given two signals, means we need to find out the output signal y of t. But here, with this large negative time shift, there is no overlap. So, here we need to change the time shift. We need to move this time shift towards right side, towards means positive side. So here this figure is going to show the overlap interval in between x of tau signal and h of t minus tau signal. So here we shifted the h of t minus tau signal towards right side, means there is an overlap area here we may found. So here the tau integration limits are going to be 0 to t plus 2. So here we consider the integration limits are from 0 to t plus 2. If we consider if tau is less than 0, the x of tau signal is going to be 0. And if we consider when tau integration limit is greater than t plus 2, we may consider the h of t minus tau is going to be 0. So, with this integration limits, we are going to find the output signal y of t. So, this y of t, by using this principle, the integration limits what we are found here from 0 to t plus 2, we are writing here. And x of tau signal is going to be e power minus 2 tau, and h of t minus tau is going to be 1 here. And after doing integration, we may find the output signal y of t in this manner. And this output signal is going to be for the limit t greater than minus 2. And this output signal y of t is going to be 0 for the limit t less than minus 2. So in this manner, we may perform the continuous time domain signal graphical convolution.